So now let's go ahead and do an example here. So let's do example 2. Excuse me. Let f of xyz equal to xyz. We will let R, the region, be the section of the unit sphere in the first octant. So in this case, the description that they gave you of the region, they didn't give it to you as an equation. They didn't tell you it's bounded by this, bounded by this, bounded by this. This time they just sort of told you qualitatively, it's the part of the sphere in the first octant. You have to figure out what the upper and lower limits of integration are. Okay, so our task is to find the integral of f over the region R. Okay, so let's just take a look at our region. I'm going ahead and draw out the full 8 octants. So this is the first octant over here. This is Z, this is Y, this is X, this is Z. So we have the unit sphere there, there, and there. That's it. So it's the section of the sphere that's just in the first octant, essentially 1/8 of the sphere. Well, let's go ahead and find, so let's convert this. I mean, since we're dealing with a sphere is ideal for dealing with spherical coordinates because the equation of a sphere is just rho. That's it, just some radius. So let's go ahead and find f of s first. So f of s, so we can put it into our integral formula here. So f of s, well, f is xyz. X is r sine phi cosine theta. Y is r sine phi sine theta. Z is rho cosine phi. So we just put them in and multiply them out. So x, y, z is equal to rho sine phi cosine theta times rho sine phi sine theta times rho cosine phi. And I end up with, I want to simplify as much as possible, so rho cubed sine squared phi cosine theta sine theta cosine phi. Okay, looks complicated, but it's easily handleable. Now we'll go ahead and do the integral. Well, let's see. First of all, let's go ahead and talk about, so rho, let's see, this is the unit sphere, so rho is going to go from 0 to 1. 0 to 1. Phi, well, phi is, it's in the first octant, so it's going to be from 0 to pi over 2. It's going to swing down through pi over 2, 90 degrees. And theta is going to go from 0, again, to pi over 2. So 0 to pi over 2. So now we're ready for our integral. Our integral equals, that's okay, I'll go ahead and do it there. Integral equals, so 0 to 1, that's going to be our rho. We have 0 to pi over 2. Let's make that our phi. So I'll go ahead and write rho and phi. It's always good to write the variables underneath. And then our theta is going to be 0, again, to pi over 2. And of course, we have our function. So we have rho cubed sine squared phi. Just got to go slow, make sure that everything is there. Cosine theta. And again, be very careful with these, particularly because you're dealing with two angles, phi and theta. Don't confuse them, which I do all the time. You know, I can give you the advice, but I make the mistake all the time myself. Cosine theta, sine theta, cosine phi. That's the function. That's the f of s part. And now we have to do the transformed volume element. So rho squared sine phi. And then we did theta first, so we do d theta, d phi, and d rho. That's it. When you put this into your mathematical software, you end up with 1 over 48. That's all. Straight, simple. You just need to be able to take a look at a particular region, try to express it, that region, in terms of, in this particular case, spherical coordinates, and decide this part right here. What's going to be happening? Rho is going to go from what to what? Phi is going to go from what to what? Theta is going to go from what to what? That's all. In this particular case, the spherical region, this is the best way to deal with it, rather than dealing with Cartesian coordinates. The integral for Cartesian coordinates is incredibly complicated. It has a lot of radicals in it. I don't even know if it's solved by, elementary methods. You might just have to rely on numerical methods to solve it if you were going to actually use the Cartesian coordinate system. So that's it. That's spherical coordinates, that's cylindrical coordinates. Hopefully we'll get a chance to do more practice in the context of other concepts. Thank you for joining us here at Educator.com. We'll see you next time. Bye-bye.